Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by special guest Professor Jeremy Webb, who we'll be introducing just shortly. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. As a little reminder, getting started this evening, York Universe does in fact broadcast live every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. UT if that's more your speed. We are broadcasting in conjunction with the online public viewing program live on YouTube. And of course, we are also a podcast, which goes live usually the day after. So if you want to catch the live broadcast, make sure you're on YouTube at York U Observatory Monday night, 9 p.m. And if you are, of course, navigating to the live show or just want to find out more, read our amazing archive, check out our website, find free tours, you can do all of that at yorku.ca/science/observatory. And of course, if you are trying to find this show, you can go to the online public viewing or OPV links, or click on any link on our website that says YouTube. It'll take you straight to the live session. And if you click on York Universe, that will take you to the podcast area. For any questions or comments you have about our past shows or suggestions for future topics, you can always email us at observe@yorku.ca. You can also find us on social media, on Instagram at York U Observatory and Facebook, and now we're on the Fediverse as well, actually, as Allan Carswell OBS. So brand new pics fed pics out there on the Fediverse and Facebook, Allan Carswell OBS. Now, and as an additional bonus, all of our programs are free. But if you would like to make a donation, you can see that same website above, yorku.ca/science/observatory, and you can help us run more of those wonderful free Wednesday tours. Our crew is monitoring the chat room for questions in the live broadcast and posting content. The current weather is not very good here in Toronto, so we'll see if we're able to open up the 1 meter telescope. We might not be able to, but even if we're closed, you can still see wonderful archival images created by our amazing team. So I'd like to just give a little shout out to our special guest this evening, Professor Jeremy Webb. Thank you so much for joining us tonight. It's great to have you here on the show. And just for people who might not have heard of Professor Webb, he's at York University, as he says himself, somewhat of a new hire. And he's done a lot of different things: education, research, outreach, and of course, research, doing gravitational dynamics, looking at stellar environments, and actually one of my own favorite things, machine learning. So very, very great to have you here tonight. Feel free to come on in and say hi.
Thank you very much, Elena. It's awesome to be here. And I'm just really excited to just chat astronomy for an hour or so with you.
Absolutely. And we have a great show lined up for tonight. But first, I just have to ask you, how's the weather where you are?
Well, I am just across the road from the observatory, so we are
Oh,
sharing the same weather.
oh dear. Well, it sounds like it is pretty cloudy for both of us.
Yep.
If it wasn't cloudy tonight in the Toronto, Ontario area, we do actually have quite a good show going on up there above the clouds. So if you are walking around in the Northern Hemisphere region um, and happen to have clear skies, there's a great set of planets lining up. It's just been a wonderful month for planets, and we'll talk more about that during the show. As our broadcast continues tonight, we will actually be making special note because we're starting the broadcast tonight just as Jupiter passes zenith over Ontario. So very, very fun. If you do happen to go look straight up and see something really, really bright at about magnitude of -2, it could well be the planet Jupiter. At least if you're in Toronto, it is pretty much directly overhead at the moment. So enough about the things we can't see um, because of all of the clouds. Boo for Toronto weather. Let's go and look a little bit with some fun history. So in this show, we always like to talk a little bit about, I suppose, fun history that's happened before. I thought we'd do just a couple little space and astronomy history fun facts, and then of course we have a bunch of other segments that are going to happen tonight. First and foremost, I thought I'd take us back in time to probably one of my favorite moments. It's just a really cool orbital dynamic, and I wasn't even on Earth to enjoy it, but I still love it. So we're going back to January 21st, or tomorrow, but in 1979. This is when Neptune becomes the furthest planet in our solar system. What about Pluto? Well, okay, so Pluto was still considered a planet in 1979. I should probably start off and say that. Um, but Neptune is something of an enigma even today. We think we know about the planets in our solar system, but Neptune, we've only really seen it just one time. We have very, very little information. It's never had an orbiter. Um, it's more than 30 times as far from the sun as Earth, and that means it is very, very cold. Out where Neptune is, the sun is just a slightly big star. It is extremely cold, extremely far, and Neptune, although it's quite large compared to Earth, you can't even see it with your naked eye. So if you're out in the sky and your star map says Neptune's out there, you will not be able to see it without substantial optical aids. So either a fair-sized telescope or a really excellent pair of binoculars. Neptune was the first planet located using math, and this is, of course, near and dear to all of, I think, theoretical physicists, and I guess we have the right person to confirm that here tonight. Now, mathematical predictions using the laws of gravity have been very popular, and there's still predictions about additional planetary-sized bodies that might be out around the orbit of Pluto or just beyond. But back in 1979, we had already discovered Neptune, and this was thanks to the mathematical predictions made over 100 years before. So the predictions were by Urbain Le Verrier and Johann Gall, who discovered mathematically in 1846 that there was something else needed. And this planet of Neptune is named after the Roman god of the sea, as suggested by Le Verrier. Thankfully, it avoided the other icy solar system planet's fate, and it got a somewhat nicer name. So Neptune is sometimes even farther from the sun than the dwarf planet Pluto. And this is what we mean when I say it's furthest planet from the sun. So even if you consider Pluto a planet, which a lot of people do still, I will add, Neptune can be farther from the sun than Pluto. And this is entirely due to Pluto's very, very, very strange orbit. So most of the planets that we think of as solid planets now have pretty circular orbits, not completely, little bit of ellipse, but Pluto is highly eccentric, which means its orbit looks more like an oval than a circle. And that oval shape actually brings it inside Neptune's orbit for a 20-year period every 248 Earth years. And that switch, where Pluto is closer to the sun than Neptune, happened most recently in 1979, January 21st. So tomorrow in 1979. And of course, it went all the way through to 1999. Now, those of you who are good at math realize that 248 years means that we are not going to see this happen again. um, But we can rest a little bit assured because, at least from what we understand of the orbits, despite the fact that Pluto goes sort of racing around and skirts in front of Neptune's orbit, it can actually never crash into Neptune because for every 3 laps that Neptune takes around the sun, Pluto makes two. So that repeating pattern actually will prevent any close approaches of Neptune and Pluto, unless, of course, something gravitationally disturbs them, which would be interesting. So there's always a chance of some rogue flyby crazy thing happening, and we've had some interesting things happen in the solar system in the past, actually. But Neptune in 1979 got all kinds of fame, as did Pluto, because Pluto zipped inside. And actually, during that 1979 to 1999 period, Pluto being so much closer actually was a little bit of a boon to being able to figure out more about Pluto. So, side benefits. Neptune is, pretty interesting from what we know of it, I should say. Its axis of rotation is tilted 28 degrees with respect to the plane of its orbit around the sun. So this is actually really similar to the axial tilts of Mars and Earth. So the seasons of Neptune actually would be very similar to the seasons of Earth. However, since the seasons of Earth are due to that axial tilt of us going around the sun once per Earth year, on Neptune, you have your axial tilt and you have to go around the sun once every Neptunian year. And its year is so long that each of the Neptune's 4 seasons actually lasts over 40 Earth years. Neptune is pretty different from Earth in a lot of other ways. It's more massive. It has 14, and I believe counting, known moons. Probably actually that number is a bit higher now. I need to check the James Webb Space Telescope data. Neptune's largest moon, Triton, is really, really interesting in and of itself and has never been closely imaged. It was discovered in 1846, around the time that the planet was discovered, and this was, a pretty massive moon, and it seems to have a lot of really interesting properties. Neptune was named after, of course, the Roman god of the sea, and so its moon, Triton, is actually named for one of the lesser sea gods, and the other moons are named for basically sea and nymph gods from Greek mythology to kind of follow the theme. And the reason we know all this, and the reason we have any pictures of Neptune from any kind of close distance, is and remains Voyager 2, which flew by Neptune in 1989, so 10 years after, of course, this interesting event about. And that was it. That was actually all. Voyager 2 remains the only spacecraft to have actually visited Neptune. Huge scandal. And of course, Neptune being such an interesting place, we would love to find out more about it. It has really, really interesting atmospheres, and of course, Neptune was also the one that had its own version of some kind of great big spot. So we've heard of the Great Red Spot on Jupiter. It had in 1989, I should say, when Voyager 2 flew by it, it had a great dark spot. And since then, we've actually seen other kinds of dark spots and things around it. And of course, Neptune has all kinds of interesting features like rings and icy structures, and we can only guess about its inside. And it has more recently been imaged by the James Webb Space Telescope, which has really helped us bring out some of the details of some of the features of Neptune. But if we really want to know more, we're just going to have to send something out there because there is a lot going on out at Neptune. So I just give a little shout out for this tomorrow, I should say, in history, as Neptune became the furthest planet in the solar system. Now, Jeremy, do you have any favorite sort of Neptune moments?
I mean, I think like you said, it's a bit of a awesome planet to look at if you're into gravitational dynamics. So just the prediction that Neptune existed in the first place because stemmed from the fact that the orbit of Uranus actually couldn't be explained just based on the gravitational pull it would experience from the sun and the other planets in the solar system, and so the fact that they just predicted Neptune from the orbital motion of Uranus was just super interesting, and it's a method that they've repeated, that astronomers have repeated, like the moons of Saturn, for example. We see gaps or the rings of Saturn. We see gaps in those rings, and those gaps are due to moons, and they've predicted the location of moons just based on the gaps. And we've even tried it was even tried for a while to use another planet, the existence of another planet, to predict to explain Mercury's orbit until Einstein came along and developed general relativity. So it's just such a cool method. And then just piggybacking on that, Neptune and the moon Triton that you brought up is also fun for dynamicists because Triton is one of the very few large moons that orbits its host planet in the opposite direction that Neptune rotates. So if you're kind of thinking looking down on Neptune's north pole and you see it rotating one way, Triton's orbiting around it in the opposite direction, which tells us a lot of cool things about Triton, potentially that it was gravitationally captured from the Kuiper Belt. So both those things are fun, and it's just a fun system to study, regardless, but especially if you're into gravitational dynamics.
Yeah, and of course, Triton is very, very interesting in so many ways. We talk a lot about Saturn's moon, Titan, with its amazing thick atmosphere, and of course, you had the Cassini-Huygens probe, and but yet Neptune, which has Triton, which has this incredible teensy tiny thin atmosphere and was one of the coldest objects ever measured in the solar system. I think it's been beaten by Pluto, but maybe not by much. It's got a retrograde orbit. It's completely bizarre, and it's spiraling inwards because of tidal acceleration, which
Right.
makes it super enticing. And we just don't know hardly anything about it. And of course, the rings and moons have been imaged by the James Webb Space Telescope, but even with Hubble images, we've seen, storm systems on Neptune changing, and there's lightning and internal heating, and just lots of really interesting stuff going on this planet.
Yeah, it's just amazing how much we're still learning about our own solar system. Like, well, at the same time, we're using JWST and Hubble Space Telescope to look at things just incredibly far away. There's still so much close to home that we still don't know and that we're waiting to discover.
Yeah, I mean, I would go so far as to say that we probably have better information on some exoplanets than we do on our own icy outer solar
Right.
system. But yeah, the Neptune exploration has been something that people have continued to put forth, and I know that there are some I think New Frontiers types of programs that are hoping to launch something to go out there. I hope they succeed and they get wonderful images.
Yeah, me too. Me too.
All right, so I think you had a potential item or object.
Oh, the Gaia spacecraft.
Oh, that's actually a news item. So let's
Yeah,
do
yeah,
that.
sorry.
Let's do that in
Yeah,
the next section. But
sounds
we'll do
good.
one more history item first. We'll
Right.
keep the history section together,
Mhm.
and we'll keep the theme as well, actually. So we've been talking a lot about Neptune, and we haven't mentioned the other one, the, the Uranian planet with the unfortunate name. And we've talked about the naming of this as Georgium Sidereus originally a few times on this program. But speaking of icy outer solar system planets, Just a few years later, after Neptune became the furthest planet in the solar system, if I go a few days farther and go 4 days from now, January 24th, but back in 1986, Voyager 2 actually does its flyby of the planet Uranus. And this was sort of the companion, I suppose, because of course Voyager 2 was also the only spacecraft to visit Neptune, as we talked about before. But in 1986, January 24th, this week in history, it was flying by Uranus, and its closest approach was 81,500 kilometers, which might sound far away until you realize that you're actually looking at a pretty big planet and you don't want to crash into it. Um, and this was a part of the Voyager 2 mission. The Voyager 2 was a amazing success, and thank goodness we had it, because if we hadn't have had Voyager 2 launching in 1977, we would not know anything. Well, we would not know nearly as much about Uranus and Neptune. We would know some things, but we would not know nearly as much. And having actual close-up images is, even though it was quite some time ago, those close-up images of Uranus and Neptune are still better quality and more detail in so many ways than anything we could ever hope to get with Hubble or JWST. Just being there makes all the difference. Your distance is too large in the icy outer solar system. So, of course, finding out what we know about Uranus really comes from Voyager 2. There has been some follow-up imaging from Hubble and from JWST on Uranus as well, but the real wealth of knowledge came from that historic flyby in 1986. And that little Voyager 2 craft, with its 1977 payload, returned a wealth of information. And of course, just as a reminder, this was the only spacecraft. This was it. We have never had another spacecraft out to visit Uranus and Neptune, those two giant planets with tons of moons. Crazy. I'm perpetually surprised by this. As much as I love Mars missions, I think we really need another Uranus and Neptune mission. So at closest approach, as I say, we were at 81,000-ish kilometers, or about 50,000 miles, and you could see the cloud tops of Uranus. We have thousands of images and reams of data from Voyager 2, and we are able to see on Uranus a complex system of rings, moons, and a really unusual magnetosphere. And I think we've talked about the magnetosphere of Uranus before, but just to bring this out, there are what can only be described as pretty large gaps in the magnetic field. The strength of the magnetic field of Uranus seems to vary a lot, and it's a very strange planet. As the flyby happened, we got 10 extra moons that had never been seen before, two extra rings, and all the planetary scientists got very excited. And a lot of them are actually still very excited about this planet. I personally feel like we should just start calling it Urania or something, but it is still very interesting in and of itself. It's the seventh planet from the sun. And it is, in a lot of ways, very similar to Neptune, and in some very crucial ways, very different. It's closer to the sun by a bit, and much like Neptune, it's gaseous, kind of cyan-colored ice giant. It's got a composition that has a lot of water, ammonia, methane, and it seems to be in some sort of supercritical phase of matter. And this is due to the density and the really extremely cold temperatures. And this is where we get into some of the lowest temperatures in the solar system. Because I told you we had, of course, the moon of Neptune, one of the coldest things ever measured. And of course, we have now measured Pluto. But Uranus is really cold in places. and the atmosphere was actually measured with a minimum temperature of only 49 Kelvin, which is only 49 degrees above absolute zero. And that's theoretical. We don't know anything that's gotten to absolute zero. That is 49 Kelvin, just so you know, is about negative 224 Celsius or negative 371 Fahrenheit. At these temperatures, everything we know of on Earth, like oxygen, nitrogen, water, they all behave very, very, very differently. And this is one of the lowest minimums in all of the solar system planets. So this is already very strange. And there's even stranger things happening next because unlike Neptune, Uranus has a very, very strong axial tilt of 82.23 degrees. This means it's knocked almost completely on its side. Something must have happened to this planet at some point in the past. And seeing this incredibly marked axial tilt, very, very strange magnetosphere, unusual low temperatures, and we have, of course, a retrograde rotation period of 17 hours and 14 minutes. And so, what this means for Uranus is that in an 84 Earth year orbital period around the sun, so it takes this planet 84 years to go around the sun, its poles are pointed either away or towards from the sun because it's knocked on its side. So the poles get 42 years of continuous sunlight, followed by 42 years of continuous darkness. So Voyager 2 really helped us understand Uranus, and of course, having it fly by was a huge benefit for planetary scientists and science fiction writers everywhere, because not only did it actually get pictures of Uranus and its ring system, it got some of the most interesting moons that have been imaged. Um, Now, I will say that unlike Neptune, you can just see Uranus with your naked eye if you know exactly where to look. It is extremely, extremely dim, and it's wasn't classified in modern astronomy as a planet until 1781. But if you are in a very, very dark sky, so one of these dark sky preserves, perhaps out somewhere in Ontario, you might just be able to see it as this faintest, littlest, tiniest star that doesn't quite move like the rest of the stars. Um, so it's been a fun one, and of course, if you're talking about modeling, I think it's caused the modelers quite some problems as well. Do you have any thoughts on this one, Jeremy?
Yeah, it's been a fun one as well. I got a lot of fun thoughts about Uranus. But yeah, when you're right, when it comes to modeling, I mean, I think our best guess is usually that it underwent some sort of giant impact of some kind in its past, whether it's a really small planet or a really large moon slammed into Uranus at some point and is responsible for tipping it on its side. But it hasn't been um, you know, that well reproduced yet. But that's just kind of one exciting thing about Uranus if you're into gravitational dynamics and modeling. For this particular event in history, it's actually interesting how Voyager 2 was able to visit not only Uranus and Neptune, but Jupiter and Saturn as well because it took advantage of something called a gravitational assist, or sometimes in sci-fi or movies they call it a gravitational slingshot. Because your first thought might be, well, how did it visit all four of the outer planets? There's huge distances involved. You know, it must have gone to Jupiter and then done some big rocket burn to get to Saturn, and then another big rocket burn. Um, to get to the other planets, meaning it would have had to bring a lot of fuel. But it turns out that when Voyager 2 was launched, the solar system was in such an ideal arrangement that it didn't really have to bring much fuel with it at all. It could just travel to Jupiter, And then while it's flying by Jupiter, there was the gravitational pull of that planet altered Voyager 2's orbit just enough, so it pointed it right at Saturn. And then once it got at Saturn, it had the right orbital trajectory that Saturn's gravitational pull altered its trajectory, and then it could go visit the other outer two planets as well. So it was just such an ideal time to launch it. They would have had to wait a significantly long time before that orientation of the four outer planets ever happened again. So it was just an awesome combination of timing and science and math that allowed those things possible. Allowed that to be.
Absolutely. Yeah, it as you say, just an awesome combination of so many factors. And I will just give a special shout out to Voyager 2 and Voyager 1, which I would just like to note are still out there. Um,
Right? They're still
they
going.
they're still going, and this has been a one of the most successful missions of all time. Like if I think of just absolutely mind-bogglingly unqualified successes, Voyager 1 and 2, launched in 1977, are still out there. They're still going. The mission elapsed time for Voyager 2, and you can check this on science.nasa.gov missions. Where are Voyager 1 and 2 now? They actually have a clock. The mission has been running for 47 years, 5 months, 0 days, 12 hours, 2 minutes, and as of this broadcast, 59 seconds.
Oh my goodness.
The distance from Earth now is incredible. They're up to 139.8 AU for Voyager 2. That's 139.8 times farther than the Earth to the Sun. That's if you took a picture of the Earth to the Sun distance, you would already have a circle on one side and very far away a small dot. And you would then have to make that distance 138.7 times out away from the sun. It is so hard to scale and so hard to imagine. We're out past 12 million miles, and I have to count that nine decimal places, billion. That's got to be a billion. Um, and it is incredible. It's going at now, with respect to the sun, the velocity is over 34,000 miles an hour. And this is, of course, because it's just kept going. It's out there in space. There's nothing to slow it down. It's just going to keep going. And if you want to talk to Voyager 2 from Earth, you can send a signal from I believe the Canberra Deep Space dish is still talking to it. But it takes about 19 hours and 23 minutes for your signal to get to Voyager 2, and another 19 hours and 23 minutes for that light signal to travel back from Voyager 2 to Earth. So we're talking to it very, 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 very slowly. And it is still out there. If you want to monitor it, the subsystems that are still working on these two crafts are pretty impressive. Voyager 2 still has its cosmic ray subsystem on, its okay, I can't say magnometer. Yes, that's how you say it. Magnometer. But they're all still on, but they've turned off a bunch of things to save power. And of course, over the years, they've had so many adventures keeping in contact with these things. But huge qualified, just unqualified success. And I think that's probably why it's still one of my favorite missions. All right. So, Jeremy, do you have any other favorite planet missions you want to cover, or shall we move on to I guess we should do our halfway announcement.
Yeah, I'll do that.
All right, so let's go ahead and just give our halfway announcement here. You folks are all listening. You might have heard this before, but you are in fact listening to York Universe tonight, broadcasting live from the Allan Carswell Observatory, where unfortunately it is still cloudy outside, so we haven't been able to open the 1 meter telescope, but the live images from the archive are being shown by our OPV crew right now over on YouTube if you're watching live, or if you are catching this as a recording on the podcast, you might want to go to yorku.ca/science/observatory and just go navigate over to the YouTube channel to watch the recording. Tonight, you're listening to Professor Jeremy Webb as a special guest talking with me, Elena Hyde, about, oh gosh, I'm making you talk about all these planets. Now we're going through the show pretty fast. I do have a little bit of an announcement, just for some observatory news in case people had missed it last week. Our official observatory fundraiser raffles are all done and wrapped up. So if you were helping to support us on our goal to the $5,000 for observatory fundraising. Thank you very, very much. The raffles that were open for the free observatory tour and the free observing session and the swag bundle, all of those raffles are done. So if you entered, you will have gotten an email, and if you won, you will have gotten a different email. So just as a little note, we were almost at our goal of $5,000. So if anyone listening would like to go and top it up, that donate area is at the very same website I've been mentioning all night. You can wander over and just if you feel like popping in a few extra dollars to get us all the way to the 5,000, we were at 4,158, I believe was the final number. And now that's the one piece of news. And again, thank you very, very much to everyone who helped us donate. That money is going to go directly to our Wednesday tours to support our wonderful work study student hours. Now, the next piece of news is in a totally different bundle. Very, very happy to announce that the Astronomer in Residence is coming back. That's right. The Allan I. Carswell Observatory is once again sending several brave astronomers out to the Bortle classified Dark Sky Preserve of Killarney Provincial Park. And we'll have you use those two telescopes out there in 2025 and summer. If you're out at the Killarney Provincial Park in Ontario, you'll be able to enjoy some unique astronomy programming. And of course, if you are browsing the observatory site, you can read the blogs and see our YouTube channel for special live streams from the telescopes at Killarney. It will happen again this year. So if you're planning on joining in, or if you'd like to apply as an astronomer in residence, it's a really unique opportunity, and applications will open at the end of January slash beginning Feb 2025, which means this year. So I'm looking forward to welcoming lots of new folks out there at the park, and that's all of the news to print for today. Our regular observatory tour will be happening this Wednesday. So if the weather is clear, or even if it's cloudy and you'd just like to see the telescopes, feel free to stop by the observatory at York University campus. And we're still in the Petrie building because it is too cold to go outside on the Arboretum parking garage. And that's this Wednesday starting around, I believe we're starting at 5:30 p.m. All right, that's all the announcements fit to print. Now we've got a whole bunch of stuff happening tonight. But first of all, let's go ahead and talk with our guest a little bit. Jeremy, it's great to have you on here as your inaugural, I suppose, York Universe broadcast. I just have to ask you a little bit about how you actually got started in astronomy outreach. How did it happen for you?
Yeah, so probably in a way by accident. I did graduate school. I did my PhD at McMaster University, where they happen to have just a really great planetarium there, the W.J. McCallion Planetarium. And so I really just signed on to do some planetarium shows, really just to make a few extra dollars, and so, as a struggling graduate student, and get a bit of outreach experience because it wasn't something I had done very much. But once I got started, doing shows for little kids, high school students, adults, fielding all these fun questions, hearing all their oohs and ahs and stuff as you're going through the show, that was really fun and a unique level of engagement that I hadn't experienced yet. So that kind of started. That was essentially kind of the first hook that got me into it. Still, while there, on a suggestion by the director, Dr. Rob Cockcraft, I created a show about the astronomy of Shakespeare, which really then took things to another level for me because it started connecting me with people that were perhaps more interested in writing or English or the history side of things, but we were able to kind of find this common median to chat and get them excited about astronomy, and they would teach me stuff as well. Interestingly, we were talking about Uranus earlier. Um, and when it was first discovered by Herschel, they tried to name it like the Georgian star or Georgian planet to honor King George, but all the other astronomers got unhappy because they weren't continuing the mythology theme of all the planets. So after settling on Uranus, once some of the moons got discovered to honor the UK or British heritage there, started naming all the moons after Shakespeare characters, which is
Ah,
really
yes, Georgium
fun.
Sidus.
Yeah, right. So that's really fun, and that gets people excited, especially if they're big Shakespeare fans. And then so it really just kept going from there. I'm really into kind of providing people with tangible, hands-on experiences when it comes to astronomy. Um, whether it's like a virtual reality or a telescope experience or even research experience, what I've been doing with an organization called Visions of Science that helps high school aged youth get some STEM experience. It's just been really fun to have that hands-on element and work with people and just chat about astronomy.
Oh yeah, absolutely. And remind me to invite you to our next Herschel Festival. But now, of course, with all the amazing astronomy going on, the last couple years, it's been, I think, almost hard to pick what to go for. But do you have any particular favorite events or event from the last few years that you really thought was just too fun not to mention?
Well, like you said, we've had so many awesome events lately, but I think for me the solar eclipse last year that we had in Ontario, that's just an astronomer's dream or astronomy outreach dream. I got to give talks at my kid's school on the day of. I got to experience that event with my kids, and my wife, which was really special. And it was one of those things where yeah, I don't know about you, Elena, but I was never a person that thought it'd be interesting or cool to go see a full solar eclipse to try to find 100% totality. But now having like experienced it in my own backyard, I totally got why people travel from all over the world to see those things. And so I would have been missing out had we not got to experience that here in Ontario.
Oh yeah.
Yeah.
And of course, I will give a little shout out to the observatory team who were all over Ontario during the eclipse event as well, and the special crew who came out to the observatory on the day for our 99 point whatever it was 8% eclipse. And we had, I think, 400 to 600 people show up on campus at York, and it was complete cloudy, but we got to see it chaos. So absolutely it was just absolutely the event of the year, I think, for many of us. And of course, those of people who weren't driving off to try to find the perfect totality spot had our hands full trying to just tell people don't look directly at the sun.
Right, right.
But just an amazing event for science and communication, and really like sharing the wonder of astronomy, which is kind of like, this is really fun, you guys. I hope you all enjoy it too, and people do, which is
Yeah,
great.
they really did. I'm like even my kids, they're like 6 and 3, and they still manage to keep the special glasses on and watch things and keep things safe. So that was really fun.
Oh,
Um,
that's excellent.
yeah, right. And then I think the other event that comes to mind, and this is maybe more than super recent, was just I bring this up all the time in my classes was Perseverance rover and Ingenuity drone landing on Mars a few years ago now. But I'm still hung up on the fact that we sent a helicopter to another world and had it fly around and help do science. And the reason I think it's really big for from an outreach point of view, is it reminds me personally of or I think what perseverance and ingenuity are for maybe kids these days is what Pathfinder and Sojourner were for me in '97. I still remember like this huge double issue with pullouts of Popular Mechanics that just went over the whole mission and how it all worked and how it was going to land. And you know, it was this tiny rover that only went a few meters, but it just got people so excited about Mars after many years of no missions to Mars. And
Oh yeah.
I feel like that rover and the drone really kind of got people excited yet again about Mars. And so I'm still excited about that a few years later.
And I would just say, if anybody would like to go and get more excited about Mars, I can only encourage it. In fact, if you want to see some of this wonderful drone footage of flying around Mars, the Martian surface, there are a very, very large list of Ingenuity flights, and this was another one that just went well past its estimated. I think it was supposed to get 7 flights or something. There are 72 flights from Ingenuity. Flight 72 was the one that showed the rotor blade damage, but they're beautiful, beautiful videos of just flying around Mars. And of course, it was the inspiration for the proposed Titan, I should say, be careful, don't get the wrong moon, the Saturn's moon Titan that has the atmosphere. They're looking at sending something over there to fly around now because of the amazing success of Ingenuity. So, you know, another great planetary crossover and just a wonderful mission, as you say.
Yeah, I think they even I heard there's even talk about sending like a submersible drone, I think, to Titan in one of the methane or the ethane lakes or something.
They've had talk of a sailboat and all
Yeah.
kinds of things, but the flyer actually has I forget exactly what the mission was. We'll put it out there in chat for somebody to go and find, and put it up as a question to our listeners. If you'd like to go and find out more, please do search that up. But there's some really, really fun missions in the works, and hopefully they do get launched.
Yeah, that's
But they're not actually launched yet. So
yeah.
if you're looking for a mission that's already launched, you'll have to go look up Juice, but that's not on our list to talk about today.
Yeah.
Um, all right, so I think we probably should move on to some news stories soon. But before we do, I thought I might just get some tips from you, as someone who's done quite a variety of different things. Do you have any tips for our science communicators in training, either at York or maybe just listening?
Yeah, absolutely. I think one would be just to find like your voice or voices, and I'm saying that find your voices plural on purpose. As an outreach or as a science communicator, you know, you're going to be talking to little kids, big kids, adults, people with varying science experience, professionals, and you're going to be using a different voice and a different language with all these people, unless of course you choose to focus on a specific demographic. And everyone's different. Some people like, you know, do outreach through a demo, through analogies. Some people are really great at getting complex science topics and getting simplified explanations of them. So everyone's different, and find a voice that works for you, and even similarly, find a medium that works for you. I remember when Twitter, you know, first came out, and even still today, there's some educators and communicators out there that just are really amazing with Twitter and connecting with so many people. And when it first came out, I remember thinking, oh, is this something I should do? Is this something that I should bandwagon, I should jump on? And after a few false starts, I realized that's not for me. That's not the type of outreach that I'm passionate about, or that I would be remotely good at. Even though you can connect to so many people, and for me, I really found it was the hands-on, direct engagement that was my strength. And so, finding a way to make the outreach your own, I think will just make your life easier. It'll make you more passionate about what you're doing, and people will be able to tell.
Absolutely. And of course, as I like to say, is if you're in astronomy in any area, whether it's research or outreach, um, finding that part that you really, really love doing is important because it does get pretty difficult.
Yeah.
So it's one of the things that can provide the sort of inspiration, I suppose, and keep it rewarding for you when it does get to be very challenging.
Right, yeah,
Um,
yeah. That part will feel just a little less like work,
yeah,
if it's the thing that you're just like, deep down, is it something you really love?
it will still make you very tired, but
Yeah,
you did get a different kind of fuel from it.
right.
So that's one of the reasons why I think it's very easy for some of us to be somewhat passionate about these things.
Yeah.
Um, Now, we had a bunch of things planned, but it turns out we're very, very good at talking about astronomy on this show. So I thought let's go ahead and cover some of the news items. There's a lot of news happening all the time in astronomy. And since we've been talking about planets, I just wanted to say if you're in Ontario, January of 2025, and anywhere in the northern hemisphere pretty much is a great time to be looking at planets. We've been talking a lot about planets, but in January we've already had Venus at its farthest distance from the sun, which means it's the easiest to see in the evening sky. Mars won't be this bright again until February 2027, and Venus and Saturn have a close approach. We've already had Mars occulted by the moon. It's been a wonderful, wonderful month for planets, and of course Mars is still close to opposition. It is past opposition. Um, its opposition was back on January 16th, but it's still pretty darn bright for Mars out there. And if you are looking at, planets in the sky tonight, if you do happen to have that clear skies, it's also rare in Ontario. You've got Venus, Jupiter, and Mars all in a wonderful line with the Pleiades. And of course, as the night goes on towards past midnight, we have the moon rising. We have Uranus up there. And of course, Neptune is not going to be visible without some big assistance. And it's also quite close to Venus. So you have to catch it a little bit earlier in the evening if you want to watch it. But there's a lot to see up there. The only one that's not particularly easy to catch right now is Mercury because it's on the other side of the sun. But this is a great month for planets. Now, I think in other news, now for something a little bit different, there's something that has been a major, major player for astronomy for several years now. And Jeremy, I saw in your item that it looks like it's coming to an end.
Yeah, it is, and I'm gonna be able to bring it back to planets actually, before we move on. So the Gaia Space Telescope is has been up in the sky since 2013 is when it was first launched, and it has been creating the most detailed map of the Milky Way we have so far. Not just positions, but the motions of stars as well. To be a bit more specific, it has completed over 1 trillion observations of over 2 billion stars. And what it does is it measures their positions in the night sky or in the sky very precisely. And if you keep measuring the position of a star over and over and over again, you can figure out how fast it's moving as well across the sky. For some stars, we even have distance measurements and how fast it's moving towards or away from us, thanks to Gaia, which means you now have 3D information on a whole bunch of stars in our galaxy, which can tell us a lot about the galaxy we live in, like the distribution of matter, including dark matter, uh, and fun things like that. And Gaia was operational doing science for nearly 12 years. And then I think it was just last week, it's ended scientific operations anyway, which means it has provided measurement of its very last star, which in a way is a little sad or bittersweet, but it's also really exciting because we there's still so much data to be downloaded and analyzed and released over the coming years. So Gaia's going to be the gift that keeps on giving for many years. And what's expected in a future data release is information about how all a bunch of the stars in Gaia's data set wiggle back and forth as Gaia studied it and observe these stars. And this wiggling back and forth, we know, is due to the presence of an exoplanet, planets going around these stars. And just doing some, back of the envelope statistical calculations, it's expected that Gaia is going to detect over 10,000 planets from its observations, which is twice as much as, or over almost twice as much as the 5,000 confirmed exoplanets that we have today. So we got a huge wealth of information on the way, not just about stars, but planets too. So I think there's a collective thank you from astronomers and astronomy lovers alike to the Gaia spacecraft.
Oh, absolutely. And of course, what we're finding, with exoplanets is that the more we can find them, we find them. And this is going to really open up a whole nother bucket of exoplanets to add to our statistics. And I can remember when we were counting in single digits with exoplanets.
Right?
And now I forget how many tens of thousands we're up to.
Yeah, it's
Uh,
5,000 confirmed, but there's
Yeah,
over
and some
10,000
large
candidates.
number of candidates. Yeah.
So
Um,
yeah, it's just nuts.
there's a lot of planets out there, guys.
Right? Apparently. What was like
And
the
yeah, the Gaia spacecraft is amazing, as you say.
Yeah,
And it's not one of these missions where like they're retiring it because they need to close the program down. The spacecraft itself actually has, I believe, a little fuel, or it's a cryogenic compressed something that's helping it keep itself exactly in position, and that fuel is running out, and that's why they have to stop. Is at least what I had read earlier.
yeah,
Um,
exactly. And it's that keeping its orientation and its position fixed so precisely that allowed it to measure the positions and velocities of all these stars. So without that capability, it is no longer able to do those measurements.
yeah, and if it can't keep itself quite still, then it's not really going to be useful for its science goals anymore. And because of its extremely large distance, it's out at L2, which is the Sun-Earth L2 Lagrange point. That's I forget exactly how far away that is, but well past the moon. And that is way too far to send anyone to add more fuel or something. So this is one of the missions where they always knew that it would have to stop when they ran out of fuel. But another one of these, just this data is going to be incredibly popular for many years to come, I believe.
Yeah, no, absolutely. And I appreciated that NASA that they saved a little bit of fuel at the end to move it out of that L2 position to make room for a future spacecraft because it's a really valuable spot to be able to put a spacecraft. So they're going to be able to
Yeah,
move it to a retirement orbit, they call it, which is kind of funny.
exactly. Well, and I mean, you don't want it to crash into like the JWST, right?
Right?
Because
Yeah, exactly.
that would be really embarrassing if it crashed into one of the other telescopes that's out there.
Yeah, yeah. So it's
Um,
a good call to move it.
and I did just find the number just as out of curiosity. The estimated number of Jupiter-sized exoplanets is in the tens of thousands. So they're estimating that from the data, with enough analysis, they'll be able to confirm tens of thousands of more Jupiter-massed planets.
Wow. That's just
Um, Super exciting.
that changes the field. It's a game changer for sure.
Absolutely. And so I think we've had lots of game changers and lots of interesting planetary discussion this evening. We'll have to wrap up our news items, the rest of our news items at some other time. But planets are awesome, and it was wonderful to have you on tonight, Jeremy. So I'm going to go ahead and finish off the evening here. Thank everyone for listening. Everybody, it's been a pleasure to have you with us this evening. You have been listening to York Universe, the astronomy and astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Professor Jeremy Webb and myself, Elena Hyde. You can always connect with us over on Instagram at York Observatory, Facebook at Allan I. Carswell OBS, and now on the Fediverse as well at Allan I. Carswell OBS. You can check out our website, show notes, content, and updates over on our wonderful website, yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies, and have a good night, everyone.
Thanks, Elena. Thanks everyone for listening. Hopefully I'm back soon.